Okay, today we are ready for our final set of naming rules. It is naming acids. Yes, I did say it is the final set, but there are 3 specific different ways we name acids. So we will look at all 3 of those and figure out how to write the formula from the name and the name from the formula for acids. So first off, if we're looking at the name, how do we know that it's an acid? Well, there's one pretty good giveaway. I want you to look for these 4 specific letters in the name. A, C, I, D. Yes, if it is an acid and we write out the name, it is going to end with the word acid. So as soon as you see that word in there, you're going to know you have to figure out which set of naming rules was used. Now, the way the rules work, it all depends on what the anion is, because all acids are hydrogen accompanied with an anion. And to this point, we've had anions that end in 3 different endings: IDE, ITE, and ATE. And the way we name our acid changes depending upon which anion is the root of our acid. We're going to start with looking at IDE. It's the one that probably seems the most complicated. The other 2 is just a simple substitution. So when you're looking at IDE, what happens is hydro goes with that root, and we'll look at how that works, but whatever root was attached to the IDE, and it changes to ic acid. And a phrase to help us remember that is, my ride has hydraulics. So IDE changes to hydroblankic acid. And we're going to look at that now as far as how that works out. So if you saw this formula here, right here, HBr, it starts with H. I didn't really talk about from the formula to the name. If it starts with H and it's not water, it's going to be an acid for the rest of this semester. So right there, I know it's an acid. So once you realize it's an acid and you're staring at that formula, you know that because you saw the H, you figure out what that anion is. In this case, that is bromide. It is an IDE anion. And all of the single elements will end in IDE. As far as the polyatomics, the only one that will really concern us would be cyanide. So most of these are going to be binary acids. We will look at the one example you'll see that's not. So what happens? IDE is replaced by IC, and it starts with hydro. So it's hydrobromic acid. That's all you do. Like, look at this one here. It starts with hydrogen. Hey, it's an acid. What is this anion? That is sulfide. You can see that on your table of anions. So all that happens, it doesn't end in IDE anymore. That becomes ic, and it starts with hydro. Hydrosulfic acid. Right here, HCl. We see what that anion was. Chlorine. So chloride was the anion. So just like the others, that IDE changes to IC, and it's hydrochloric acid. We may have lost the end of that there, but you guys should know what I was typing. It's what we said right here, hydrochloric acid. Have one more example here of this type from the formula of the name, HCN. The first time we've seen multiple elements there, it has to be a polyatomic. Most of the time, those are going to end in ITE or ATE, but when we look up CN, we will see that that is cyanide. I will change that IDE to IC, and it starts with hydro, so it's hydrocyanic acid. Anytime the anion is an IDE root, it looks like this. Hydro with that root and ic, an acid. And if you're going from the name to the formula, it's the same rule just in reverse. So if you see the word acid and you know it's an acid, and it starts with hydro, this is going to be an IDE ion. So you just figure out fluoric, figure out what fluoride was, and you look and say, hey, that is F, and you look at its charge, because acids do combine ionically. Fluoride ion is a -1. It needs 1 hydrogen, HF. Here's the one we looked at over there, hydrocyanic acid. It's an acid. It starts with hydro. I'm going to figure out what IDE that came from. And I see that it is cyanide, CN. And it has a -1 charge. So it gets 1 hydrogen as well. HCN is hydrocyanic acid. I'm going to put another example here. So we see hydro. We will put sulfuric. Hydrosulfuric acid. So acid, hydro. I know that this is the IDE because only IDE anions end up being hydroblankic. So sulfide. So I figure what that is. It's S. It has a 2- charge. So hydrogens +1, I need 2 hydrogens for that one. H2S would be hydrosulfuric acid. Okay, we're going to flip around and look at our other 2 naming rules. So give me a moment to get rid of it. Okay, we've got that switched over. So now we're going to look at our other 2 endings here to see what happens for our ITE and ATE anions when they are teamed with hydrogen to form an acid. So the ATEs simply interchange with IC. So ATE and IC interchange. ITE interchanges with OUS. And we'll look at how that works. There's phrases to remember that. I ate something icky. Ate and ick. Flip back and forth. I ate something icky. And Sprite is delicious. Our 2 phrases. Sprite is delicious. I ate something icky. How does that work out? Let's look at it going both ways. So here we have some acid formulas to look at. We have H2CO3 is the first one we're going to look at right there. Well, that was, I apologize. That was from my mic cord getting trapped. Okay. So when you see the formula, starts with hydrogen, I know it's going to be an acid, you've got to figure out what CO3 is. And when you look that up, you'll see that it is carbonate. So our root anion there is carbonate. And from over here, 8 just interchanges with ick. We simply flip them out. So instead of carbon 8, you get rid of the ATE, you put your ick in and add the word acid. So hydrogen with carbonate gives us carbonic acid because 8 changed to ick. And look at these 2 right here. We have HNO3 and HNO2. They both start with hydrogen. These both have more than 1 element. I'm going to find them on the polyatomic, and I looked them up. I see that NO3 is nitrate, and NO2 is nitrite. Now, I ate something icky. Ate and ick interchange, so you just get rid of ATE, put in IC, acid, nitric acid. Sprite is delicious. That was our other phrase up here. Sprite is delicious. ITE changes with OUS, so you just get rid of the ITE and replace it with OUS, nitrous acid. That is it. If you're going the other way, it's not too hard. We see the name acid. We know it's acids. It doesn't start with hydro, So if it doesn't start with hydro and it's an acid, these are going to come from ITE and ATE anions. So if it's oxalic acid, just remember that ick changes with ATE. I ate something icky. So what I'm looking for is oxalate. If I see oxalic acid, I have to look up oxalate on my table of ions. And you guys all have that here. So when you look up oxalate there, it should be C2O4, yes. So you look up oxalate and it's C2O4 with a 2- charge. So when it combines with hydrogen, since it's got 2 minuses, it's going to need 2 hydrogens. So you have H2C2O4, oxalic acid. Oxalate ion requires 2 hydrogens. So here we have chromic acid. So IC, so what you're going to look for is you're going to look up chromate and see what the heck chromate is. You have this. When you look at it, it's CrO4, and it has a 2- charge. The charge tells us how many hydrogens it will need when it combines, because you'll need 1 hydrogen to counter each negative. So I need 2 of them, H2CrO4. That would be chromic acid. Then I have chlorous acid. Here we see an OUS one. That's our ITE. So I have to look up chlorite. When you look that up, it's ClO2 with a -1 charge. It only needs 1 hydrogen. So that hydrogen goes in right there, and it's HClO2, chlorous acid. So keep in mind, when you're naming these acids, it all comes down to what the anion is. If it was IDE anion, it uses the hydroblankic acid form. If it was ATE, you simply drop that and put IC in its place. If it was ITE, you simply drop that and put OUS in its place. And they all end in the word acid. They all start with the element H, or hydrogen. Thank you. I look forward to seeing you guys at some point.